Welcome to the Sustainable Business Council's April Sustainability Shot. This is the last of this school year's shot series. Next fall we'll be holding them in fall, all three of them, so they'll be September, October, and November, so we're looking forward to those in fall. This particular, I'm Sue Anderson, by the way. I'm the Administrative Coordinator for the Sustainable Business Council. We have a number of our board members here with us tonight, including Carolyn Sims, Lori Bridgman, Liz Dye, Rod Austin, and Rebecca McClellan. Most of them have their name tags on. There's a few who forgot, but you'll be able to pick them out after the event if you want to chat with them a little bit more about what SBC is all about and how we do these, put these events on, etc. Our sponsors for tonight's program are Family Dental Group, Energetechs, Portico Real Estate, The Loft, the Indy, Cherry Creek Radio, and for those of you who haven't been down to the food line yet, Bravo Catering brought that food over and it is tremendous. We also have beer here from Big Sky Brewing, wine from 10 Spoon Winery, and the Liquid Planet also gave us, so we have a wide selection of wines over there for you to try. By all means, we'd like to see a lot of that be eaten before you go, so the requirement is after you get done listening to the lecture that you go through the line again, of course. Tonight's lecture is Commercial Buildings and Energy Efficiency for Your Bottom Line. One of the things the number of studies have shown us recently is that our buildings are a big chunk of energy use in the United States, and most buildings have a fair amount of energy efficiency that you could reap, or gains that you could have through energy efficiency from either retrofitting the building or obviously tearing it down and building a new building. but our speaker tonight is Skander Spies. He is with Energetechs, and he is a residential energy performance contractor. He has his undergraduate degree in mechanical engineering, and while he was there, he focused on energy and sustainability and energy engineering and how you combined all those things. So he's got lots of experience in that. He has spent a fair amount of time dealing with commercial buildings across the West, and has also been doing a fair amount of work in simulation of energy use by buildings, so he knows the ins and outs of how a building uses energy. While he's not working for sustainability, etc., he is also a classical cellist, a jazz bassist, and a rock climber, trail runner, ice climber, and skier. And he spent 500 hours volunteering in Denali National Park up in Alaska. So if you want to catch him afterwards to find about his other life, there's obviously some exciting things to chat about there. I wanted to, real quickly before I skip on, how many folks heard about this event through a newspaper ad? And was that just today?
Yesterday, actually.
It was out yesterday. Okay. Yeah, it should have been out for a week or more, and I might have gotten my timing wrong with the paper. How many folks heard about this through social media? Nobody. One.
Or email.
Email. So one of our email blasts.
Right.
So email blasts. Okay. Great. Thank you for that help. It just lets us know where we're reaching people and where we're not. I hope you enjoy Skander's presentation on commercial buildings, and he's going to try and hold it to about 20 minutes so that you guys can get your own in-depth questions answered on your commercial buildings when he's done. So we'll see how well he does with his time clock. Come on up, Skander. This one's for MCAT, so you need to make certain you don't lose that in the process.
Okay, cool. Sue, thanks so much for having me tonight. It's really a pleasure to be here. Thank you all so much for coming tonight, and to the SBC board for putting this event on. It's really a privilege. My name is Skander Spies. I'm a project manager for Energetechs, which means I wear a lot of hats per Sue's introductions. But we are really going to focus on commercial building energy efficiency opportunities, and with the emphasis of, making more money. Who wants to make more money? That's not a shame. Yeah. So who rents space, either to live in or to work in? Cool. Who owns space? Sweet. Who owns a business? Right on. So I think we've got something for everybody. Just before we go any further, I want to talk a little bit more specifically about what exactly Energetechs does. We do residential and commercial building comprehensive audits. Our audits look at energy use. They also look at durability, indoor air quality, health and safety issues, water management issues, so really the whole picture. And that idea of the whole picture is going to recur throughout this presentation. We also do a lot of consulting on net zero buildings. Sue talked about my background in energy simulation, so we do a lot of estimating energy use in buildings so that we know before we build a building how much energy is it going to use. And a net zero building is built around the idea that this building will be able to produce as much energy on site as it consumes. And then we're an installing contractor, a licensed contractor in Montana, and we install HVAC windows, high performance windows, and insulation systems on all kinds of buildings. So tonight, just the summary of what we're going to hit on, talk a little bit about defining energy efficiency projects. Sometimes there are a number of different definitions that we can look at there, and I just want to make sure we're all on the same page. We're going to talk about the value to society, the value to building owners, and the value to tenants. There are different ways that energy efficiency retrofits and new construction can really benefit each of these groups. And so we'll talk about a couple of different examples. We'll talk about a little bit of real estate finance. We'll see how well I do with that. And hopefully talk about some buildings that you guys have been in as well. So defining efficiency. A lot of times people call us to figure out what's going on with their building. Maybe one of their workers is getting sick, or maybe everybody's just uncomfortable, or maybe they notice that they pay really high utility bills every month and it's hitting their bottom line and they really can't afford that. So who's heard of LEED certified buildings? Pretty much everybody. That's awesome. LEED is a great standard for trying to understand the sustainability of buildings. It's one particular, it focuses on a few particular segments of building performance. We have building codes, there's something called Energy Star, which is another way to rate building performance. But what we notice is that there's this direct correlation between energy consumption, the indoor air quality, and the comfort of a space, the overall building durability. Durability deals with things like maintenance and reliability of systems. And what we're talking about when we really, at least at Energetechs for the work that we really like to do, we're going to be talking tonight about projects that go in excess of code minimum requirements. Code is basically the legal minimum that you have to meet to be legal. And very often, particularly in commercial buildings, it can be really difficult to justify any additional expense to go beyond code minimum requirements. The interesting thing that we've seen on a number of our recent past projects is that going very well beyond code minimum didn't actually cost any more, and probably and absolutely in the long term cost less for the owner. So value to society. We're here probably because most of you care about the sustainability of our society as a whole. And so we're going to talk, and this is kind of the first thing that people think about when we talk about energy efficiency. It's the dollars that you save by not using energy that you don't really need to use. Sue talked about kind of our total national consumption. Buildings make up about 72% of all energy consumed in the United States. Commercial buildings are about 20%, and residences are a little bit more than 20%. In Montana, this graph looks a little bit different because we have a lot of buildings that would probably be classified as residential buildings, but there are people operating businesses out of them. We have a lot of smaller buildings. And from this presentation, really the buildings that we're going to talk about are from 2,000 square feet to 100,000 square feet. Most of them were built in, between now and 1970. And that's where we see a huge amount of opportunity. We're not going to be looking at large hospital complexes, ultra large retail shopping centers, or manufacturing facilities. So we're really, how many people work in a building that fits in that category of 2,000 to 100,000 square feet? That's most of us. So when our office is really busy in August, September, October, we're a small construction company, we're managing a whole bunch of projects, we get utility bills, just like we do every other month of the year. When we're slow in February, when we're catching up on our marketing and our follow-ups, and we're kind of poking people for work next year, we get utility bills, and they're about the same. It doesn't really matter whether we're busy or slow. And I'd say that's true for many of the clients that we talk to. It's probably true for many of you that your business output isn't directly tied to your energy consumption. That means that we can cut energy consumption and cut that overhead cost without cutting your business output. So the cost savings that we're looking at really can be influential. If you're operating a small business, your energy costs work directly against your bottom line. So any incremental improvement that you can make is going to make a difference in the profit that you realize. And then realistic opportunities. Kind of as Sue mentioned as well, in these buildings between 2,000 and 100,000 square feet and built, a lot of them were built in the 70s and 80s and early 90s. Those buildings are 20 and 30 and 40 years old now, and there are a lot of opportunities. We know a lot more about how to build energy efficient buildings now than we did then. And we know how to implement things better. We have better tools and materials. So we see a lot of opportunities in that sector of buildings. So I dug up some data. There's something called the CBEX survey, which the Department of Energy conducts every year. It's the Commercial Building Energy Consumption Survey. And they had 262 buildings that fit this category. And this is where those buildings use energy. So our total comes in at about 93. And the units are in 1,000 BTU per square foot per year, but it doesn't really matter. About half of that is heating, about 20% is lighting, and about 10% is ventilation and air conditioning. I want to call out ventilation because there's not a lot of cost, or not a lot of energy cost associated with it, but ventilation is really important for the indoor air quality in a building and the long-term building durability. We'll talk a little bit more about that later. And then this category of other encompasses things like water heating or anything you plug into the wall, your computer, your printer, and your refrigeration equipment you might have, even some task lighting if you're in a retail facility. So that's kind of where we're using energy in these buildings. If we just cut heating and lighting by 50%, which is actually pretty easy to do, we'd see about a 30% drop, 35% drop in overall consumption. So can we do that? I wanted to look at a quick case study. This came out a little darker than I wanted, but this is 740 Higgins. It's at the corner of 6th and Higgins. Who's seen this building? Who's driven past it? Pretty much everybody knows. So there are 8 residential apartments on the second level, and there are 3 commercial spaces on the first level. It's owned, the building owner is also the operator, and in that he's responsible for the utility costs. So those 8 residential units are all served by one heating system. And they called us because they had a problem. They had a 50-year-old steam boiler that was gobbling up energy and gobbling up maintenance budgets. And they wanted to do something better. They weren't exactly sure what, but they had, a lot of the residents were opening their windows all winter, which to cool off their apartments because they were overheating. And people who have lived in New York have certainly seen this as well. And because there was only one heating system, and there was actually only one thermostat for all 8 apartments, which didn't work very well, the owner was paying whatever the utility bills were, fluctuating from month to month, and charging a flat fee that was worked into the lease agreement, which means there was no incentive for residents not to open their windows to try and cool themselves off. There's lots of incentive for the owner to try and address the issue. And so we looked at just replacing the boiler. Same steam boiler, same relatively low efficient system. It was a code minimum boiler. And they were going to be in it for $17,000. But we knew as the contractor, as an installer, they weren't going to be happy if we put in a new boiler. So we ended up replacing the entire heating system, which seems like drastic measures, and it ended up costing about $60,000, but we installed a system that's going to last 50 years and gives individual control to all 8 apartment units and has additional capacity for the commercial units if they want to take advantage of it. We cut heating use in half, so they're saving $3,000 a year. So the owner's pretty psyched. We finished the retrofit in July last year, and so this is the data that we got after this winter. And granted, it was a mild winter. More severe winter, we would see even more savings. They have 0 complaints. They have 0 open windows this winter, and we cut out $650 a year in maintenance. They're pretty happy. So that's the numbers and cents, the dollars and cents of what we ended up doing there. Back to that previous slide, cutting heating use by 50% is pretty doable. Now we're going to jump into some of the real estate finance side. So value to owners. If you own a building, you want it to maintain value. You want to see your asset value as high as it can be. In typical real estate investment world, asset value is defined as your net operating income divided by your capitalization rate. Your net operating income is the income you get after expenses, and your cap rate is essentially how much return on investment is required by the investor to justify investing in the property. So if we want to increase asset value, we either increase net operating income or we decrease the risk associated with investing in the building. So ways to increase operating income. I know that as a renter, I'm more than happy to consider paying a higher rent if I know that my utility bills are lower. So you can justify higher rents, and we've seen this in the market. As an owner, you also really want dedicated tenants. You want low tenant turnover. You want tenants that care about the spaces that they occupy. And whether that's a residential tenant or a commercial tenant, it's good for everybody. It's good as a renter, it's good as an owner to have dedicated spaces that people are really happy running their businesses and living their lives in. So you want to decrease your expenses. So reduced maintenance is obviously a big example of that in the previous case study that we looked at. And there are also some tax depreciation advantages that'll reduce your tax bills at the end of the year. And some of those maintenance costs really don't get considered when you're looking at straight payback on energy efficiency and utility dollar savings. And then you want to increase your reimbursements. So energy incentives, they're out there. There are federal incentives, there are state incentives. There are good things that we can do for buildings that increase that overall income strategy. So your gross income minus losses from vacancy minus expenses plus reimbursements increases your net operating income. So next we're going to look at capitalization rate. So what plays into the risk that investors see in a building? How do we decrease that risk that's associated with building investments? So energy efficiency improvements really hedge your bets against future codes and regulations, and they open up the opportunities that you have later to make high quality improvements that are going to really attract dedicated tenants and basically set you up for the future much better. Liability for health and mold concerns. We did a big retrofit down in Southwest Higgins that was driven by the fact that they had sick employees and they didn't know what to do with it. And that really ended up costing one firm in particular quite a lot of money. More efficient buildings and buildings with better quality systems cost less to insure. And again, you see the same depreciation advantages. All of these factors reduce risk to owners and investors. So these are things that we see get left out of the equation pretty often when we start talking about energy efficiency and comfort and health and safety improvements. So next I want to talk about the value to tenants. And really this centers not so much around energy consumption, but it centers around your business operations, and it centers around the healthy spaces that we want to occupy. It centers around how comfortable are we and how less productive are we if we're uncomfortable. So this is a cool graph, and the next couple of slides I got from a study done by Rocky Mountain Institute. They're a think tank out of Colorado. They do a lot of research in energy efficiency work. But the thing that I really want to highlight is that in the grand scheme of running a business, the expensive part is your employees. The next expensive part is your rent. And if you're a retailer, your inventory costs are usually pretty high on this graph too, but they didn't have those. Your total energy costs are really small. If you want to make more money, which most of us did when we got here, you could either reduce your energy bills or you could increase your productivity. If you increase your productivity 1%, you get rid of all your energy costs. So there's the study that Rocky Mountain Institute did. It's called Greening the Building in the Bottom Line. I did scab the title for this talk. And Rocky Mountain Institute is pretty sure, having done this study, that making energy efficiency improvements is really tightly correlated to health and safety and indoor air quality renovations and improvements. And those improvements are the fastest way and the cheapest way to increase your productivity. 2 quick case studies. Pennsylvania Power and Light did a retrofit just to the lighting systems in 25% of their drafting space. So they have surveyors and civil engineers that do drafting work all the time. They're always looking at big plans, reviewing documents. It's very eye-intensive work. They invested $8,000 to retrofit the lighting in 25% of the space. They saw an immediate 13.2% increase in productivity, and in the first year, they saw $42,000 in increased revenues from that department. Not to mention, they saved $2,000 in lighting energy costs. So, yeah, when we look at strict payback for the utility costs saved, it pays back in 4 years, which is actually pretty good for most retrofits. But when you really look at $42,000 in increased revenue, it pays back in 2 months. Who doesn't want to do this? Next example is for a new construction building. West Bend Insurance did a new building right next to their old building, same corporate property. They built it for $90 a square foot in 1991. And one of the biggest things that they really wanted to do for their employees was provide individualized comfort control. This is pretty similar to what we did over at 740 Higgins when we gave each apartment their own comfort control. Their payroll is about $12 million, and after the first year, they saw a 2.8% increase in productivity, which resulted in $364,000 in returned revenue. They're an insurance company, so their metric is really claims processed. So how many claims did they process? How well did their employees do? Not to mention, they reduced their utility bills by 38%, which is no small chunk of change either. The interesting thing about this study is that they went around and they wanted to gauge the impact of this individual comfort control on their employees. And so they asked employees to give up their individual comfort controls for 2 weeks at a time. And about 12% of their employees, when asked to give up their comfort controls, said, "No, I'm going home immediately." They weren't willing to work without them. And so they got omitted from the productivity study. But I thought that was a really interesting thing to note, that once you've empowered your employees with these kind of controls and with this kind of productivity, because I know I like getting more done at work. I feel better about myself if I'm getting more stuff done. It doesn't necessarily matter if I'm more comfortable, I just notice that I get more done. Then that's pretty compelling. So we kind of saw this all come together at the Five Valleys Land Trust building. Who's been in the new Five Valleys Land Trust building? A couple folks. What was it like to be in there? How would you describe the space?
Airy, light.
Awesome. Dave?
Yeah, really comfortable.
Sweet. They're really excited. And really the big shout out on this project goes to Kim and Ruth Reineking and Lucas Dupuy of Sustainable Building Design. The Reinekings are with Five Valleys Land Trust and First Interstate Bank and Reineking Construction. Kim and Ruth couldn't be here tonight, but they are really excited that we're talking about their building. They also own the building. And they had a goal from the beginning to make sustainability a priority. They were also limited by the market. They went to the same bank and had the same borrowing rights and had the same down payment that most commercial developers would have. But they made it a priority to put in 60% better windows, 50% better wall insulation, and 15% better heating and cooling systems. They knew that it was going to be worth it. So it's a 5,000 square foot office building. The average office building from our study earlier that we were talking about goes through about $530 a month in utility costs. Five Valleys Land Trust uses $150. It's about 70% better, and it's $5,000 a year that Five Valleys Land Trust doesn't have to fundraise. So, the value to society in reduced resource, that's $5,000 more a year that Five Valleys can put towards preserving lands, which I think we all are in favor of. And their building is not really using that much energy. So the Ryan Kings are pretty psyched about this because they have a tenant that's really, really excited about being in that space. They've seen very, very low maintenance costs, and we'll obviously be tracking the maintenance costs pretty tightly over the next couple of years. The building's been occupied for just about a year, so we're only looking at about a year's worth of data. They filed their taxes, shortly before I asked them for a bunch of data for this talk, and they were like, man, don't forget the tax appreciation advantages. The tax depreciation is worth a lot. They weren't prepared to tell me how much, but that's okay, it's their rights. And they have, they renovated a new Class A office space in Missoula. That's a premium product that there's not a whole lot of. So they feel like they have a pretty clutch chip in the market. The values to the tenants is that Five Valleys Land Trust has a building that really reflects the values of their organization. They're a conservation land trust. They want to be connected to the outdoors. They want people who come into their space to think that it's light and airy and welcoming and comfortable. It's quiet, and it's got a ton of awesome natural light. So we've certainly had some challenges. The whole team had challenges. The existing building shell was not easy to work with. It was pretty run down. It was pretty difficult to get that much insulation and really good quality windows to sit in the building. I did already mention that Kim and Ruth were up against market rate financing. They knew they could only lease out the space for so many dollars, and they were only able to borrow so many dollars. So they were on a pretty fixed budget. And they knew that the tenant that they wanted in there, Five Valleys Land Trust, really wanted a space that reflected those same values, and they were going to demand that, or they were prepared to find a building that really worked for them. So how did it all come together? They started with an energy audit. They hired Energetechs. We did an audit. We came up with a pretty clear plan for who would need to be on the team and kind of what our finished product would start to look like and how that could be done for this existing building. Kim and Ruth really laid it down. They said, these are our goals, and they stuck to those goals all the way through the project, and they didn't let them slide. And they solicited a lot of feedback, and they were really humble, and everybody on the design team was really humble in saying, this was the goal, this is what we want to get to, what can we do to make sure that it happens? And if I've got to change my insulation system, that's cool. If we have to change, maybe some of the interior finishings so we have more budget for something else, that's fine. If we're going to change the look of the building, okay, but this is the goal. So I think I already covered that one, but what did we end up with? Our 30 in the walls, our 60 in the ceiling, our 5 windows, a pretty small heating and cooling system, and a really airtight building. This is one of the biggest things we see on kind of this class of buildings that we're talking about, 2,000 to 100,000 square feet. They have lots of uncontrolled air leakage, and sometimes that can be a pretty hazardous thing for building. And that's also where you lose a lot of energy. So this is just one of the metrics that we use around air tightness. Montana State Code holds us to 4.00 ACH50, so we're about 8 times better than code on the air tightness. So just a few things that I'm really hoping you take away is that energy efficiency improvements aren't really just about energy. They're about comfort and durability and health for you and your employees, and that can have a really direct impact on your productivity. Very often it starts with an audit. It starts with figuring out what you have. It starts with coming up with a really clear plan before you draw plans, before you get your heart set on, I want this. Create some real clear goals and come up with a plan, work with contractors, work with architects, work with everybody at the table to mold those goals into something that you want. And don't be afraid to really push beyond code. It's not that much more expensive. My name is Skander Spies, and I would love to take your questions.
please repeat any questions that people say so that we make certain to get it for the TV audience as well.
Sure.
Just a quick, is Rocky Mountain Institute Amory Levins?
Yes, Rocky Mountain Institute is run by Amory Levins and a couple other pretty rad people too.
What's the size of Five Valleys office space, and how are they cooling it?
They've got a rooftop unit that's a dedicated rooftop cooler. It's a forced air system. It's 5,000 square feet. They also have what's called an airside economizer on the building, which brings in fresh air directly, and it'll vary the amount of fresh air that it's bringing in. If they need, if the building needs cooling and it's 72 degrees outside, you can do cooling with, well, I guess that example's not great, but if you want to maintain your interior space at say 75, and it's 68 degrees outside, it'll bring in a much larger volume of outside air to cool down the space without using any compressor energy. Yes, ma'am.
I was just wondering, the first building that you talked about, they spent $60,000 to change their heating system,
Mm-hmm.
and they saved $3,000 a year.
Mm-hmm.
So I think, is that a 20-year payback?
Yeah.
Is
So
that good? I don't. How many
Repeat the
years is a good sum? And of course, there's the tax credits and all that too. But
sure,
they just
absolutely.
said they were really excited, and I thought, that's 20 years it's going to take before they actually see a return. So
Yeah.
I just wondered.
So the question was that we spent $60,000 at 740 Higgins, and we're saving about $3,000 a year in energy costs. That does work out to about a 20-year payback, and I mentioned that the client that we were working for is pretty excited about that. And yes, 20 years is a pretty long payback. No investor, no commercial institutional investor would ever really accept 20-year payback. This is not a commercial institutional investor. This is an owner who's directly operating his building. I'd really encourage you to not miss the $650 a year in maintenance that was in addition to the $3,000 a year in energy costs. So, when you consider that, that makes your payback more like 14 or 15 years, which is still not institutional grade investment return at all. But it was worth it to the owner to make the investment in their property because they wanted to attract dedicated tenants. They wanted to install a system that was really, more like a 50-year system. So we didn't end up replacing we ended up replacing the boiler. We also ended up replacing all of the piping, all of the pumping, all of the control valves, all of the radiators, all new controls throughout the building. It's a system that's probably going to last 50 years. And I wanted, I mentioned in the beginning too, we could have just replaced the boiler with basically the exact same thing that was there for $17,000. So I would kind of look at the capital cost of the project as being more like $43,000 was the additional. You're stuck at 17 no matter what.
Yeah. And also, just one more thing, the owner probably planned on keeping the property, I would think.
Yeah.
And so long-term, it was going to pay off.
Yeah, absolutely. I think how long an owner plans to be involved with the building definitely plays in. Just, I'd love for Russ Hellum, who is the boss of Energetechs, speak up a little bit.
Yeah, I just add to that on that project. That data is actually only from August until now. So there's $3,000 in savings in the last 7-8 months. If we kind of extrapolated that out annually, looking around $4,000. So the $4,000 plus the maintenance and service, the time period looks better than 20 years. So.
I'd like to go in order actually, if you don't mind. Go ahead.
Just real quickly though, from like an investment standpoint, would that dramatically increase the value of the property substantially? Like if they were to try and sell it before the upgrades and now after, not working about a yearly savings, but I'm talking about like a value of what the property is.
So the question was, wouldn't that change the real estate value of the property? And that's kind of what we're talking about in the second part of this talk, looking at asset value, is that is a building with a 50-year-old heating system that has huge reliability issues. it would be assessed one value, and if there were an investor, looking to buy the property, that seems like a pretty risky investment to me. That seems like a lot of liability to absorb with purchasing a building. But if it's got a brand new heating system that I know is going to be super reliable, that's really a better design system for that building, it seems like that's way less risk. So that asset value goes up.
Also, this is a small town and word of mouth is a big deal, marketing wise. So if you have, a building that's desirable and it's located in the center of town the way this one is, you can always be sure that good things will be said from tenants who now leave. And then there's nothing saying that the rent will stay static. It won't. And therefore, there's going to be the ability to put that in play when asking renters who are staying to either pay more, increase the rent, incrementally, as well as new renters who would take on the apartments as they become available. So, and over the course of time, $60,000 over the course of 20 years is not as much as it may look to us now.
One of the other asset valuation strategies that real estate folks really look at, and investors in particular, is the net present value of money, and kind of looking at the value of money today versus the value of that same money down the road. I didn't really get into that example at all. We can have that conversation offline, but it's certainly another way to look at money, and I think it only makes things look better.
So you alluded to a few costs that you really didn't get around to yet that might be possible savings, and I assume that's what's happening some in this building too. Going from an old boiler to a new system, I assume his insurance cost dropped significantly, and
Newer's better.
the other thing that I would also assume is, and this is a number that gets buried in most companies' bottom lines, you kind of get at it with the productivity, but absenteeism in a workplace or vacancy in a rental facility costs an owner a whole bunch, and we often never put it in with these energy, you put in a new energy system, and it's going to mean your vacancy rate's going to drop, and your employee absenteeism are going to drop when you have a system that doesn't make people sick, and they're not cold all the time, and they're not hot all the time. Those sorts of things. Those are numbers that are rarely pulled out. That's not in that productivity number. There's additional things that go into that number. Have you seen any studies that have tried to pull out all of those little pieces?
We have. I've definitely looked into some of those studies. So the question is around some of the other pieces connected to productivity and employee health, such as sick time taken or absenteeism or employee turnover. And getting that data is pretty difficult. Department of Energy did a study on 5 buildings that I didn't end up pulling for this presentation, but they saw all of those things to be true. I didn't happen to mention, but in the example of Pennsylvania Power and Light, they saw 25% less sick time taken, so their employees were present more often. I suspect that probably was captured in this $42,000 in increased revenue because people were there working more often, but I think as a business operator, that would be a pretty big motivator to keep your employees happy and healthy.
Can you walk us through the numbers of the 5 alleys? Remodel, you said it was $110, $120 per square foot. They're saving, what did you mention, $5,000 a year? What's $4,600 a year savings. What's going to be the payback rate on that?
Well, I think the energy savings alone don't really play in because, the building owners started from zero. They started from a shell of an empty warehouse, and they said, we want to make this into an investment office space. And so
it wasn't previously office space, though.
It wasn't previously office space. And they went out and looked around the market and said, well, Kim Reineking is a very experienced general contractor. He's done a lot of different projects, and the going rate for pretty much any major commercial building or renovation work right now is about $120 a square foot. And so that's pretty much what his budget was. And so it was, kind of not so much how big is the pie, but how is the pie split.
And that savings is based on average cold climate building, not actuals from that space, is that
Correct. So, question was where's the average coming from? But it's coming from that original study of 262 buildings that the Department of Energy does, and that is specific to our climate zone. So that's buildings basically from about Spokane to about Minneapolis, and down into Wisconsin.
So along those same lines, he could have paid, I just want to clarify, he could have paid $120 an hour or per square foot for any type of materials he wanted, but without the same cost savings.
No way.
In the Energetechs.
No.
Is that accurate?
No, that's not accurate.
Well, I think he could have done it. So the question was, the owner built the building for $120 a square foot, and he would have paid the same would he have paid the same for any materials? And that's not true. You could definitely do it cheaper than that, but that's basically what he was limited to by his financing. That was what the market would support for him to do that. Knowing that he wanted, I'm not sure that you could do Class A office space for very much less than that. I'm sure there are many opinions on that, but just doing a renovation to get some office space, you could certainly do it for a lot less money. Yes, sir.
Well, considering the same building that you're talking about, what were the strategies that you went through, and what was it really eliminated by getting to that $120 a square foot? Because you didn't, you showed the finish in there as pretty much gypsum wallboard, and, kind of hard finishes, and I was wondering, like the windows are just sort of placed on the outside face rather than having shading. You got a lot of contrasting lighting inside the building. And I'm just wondering how it is that you went through your strategies to come to this solution that was, your $120 a square foot.
Sure. A lot of it was upfront budgeting. So before anything really got designed, kind of throwing around what's called a massing model in architecture to say this is approximately what it's going to look like. This is approximately how many windows we're going to need. This is approximately, this is the level of insulation that we need and the amount of space that we're going to encapsulate to meet the building program. So that was a big part of it. Dana Lund is a very talented lighting designer. He really helped out with creating a very energy efficient lighting system and control system, but also with window placement and window tuning. There isn't a lot of shading on the building because of the site of the building. It faces primarily north. It's shaded by a large hill to the south, so it doesn't really get the same solar heat gain that a lot of buildings with big south-facing facades get. Sorry, what was the last piece?
Well, just a question on the strategies and how you maybe thought of one and eliminated one, and versus what it was you actually, finalized and came up with. What were comparing? In comparison, what were strategies that you threw out? You said, no, this isn't going to work in that budget.
Spray foam in the walls.
Yeah.
Spray foam in the wall.
From an insulation standpoint, there's a lot of surface area of walls, and we looked at different strategies with the general contractor to talk about, okay, how can we get a high R value building system, and within this budget that we're working with. And so we came up with a strategy that worked. It gave us the R30 walls without using all the spray foam, which costs a lot of money.
One of the other things that we did was we really worked hard with Dana to come up with a window package where we kind of picked and choose where we had operable windows versus fixed windows. Fixed windows are way cheaper than operable windows. And so kind of by making some strategic choices about where do we actually need access to outdoor air, where do we really have people working at their desks 24 hours a day versus where do we have, maybe just static space or hallway space, or space that isn't used very often or is not likely to need access to the outdoors. I think a lot of people, especially looking at window replacements, say, oh, I'm just going to replace what's there. Well, can we go to a cheaper kind of window that still offers great energy performance but maybe is cheaper to build? a like a sliding double hung window is a pretty expensive window compared to a simpler casement window.
And
And less efficient.
we weren't involved in all of the decisions around finishes and desks and all that sort of stuff. I'm sure there was a lot of conversation with the designer and the builder and the occupant, the tenant, around those decisions. That wasn't our role on this project, so we can't necessarily speak to the trade-offs that were made on that part of the project.
Well, so how much influence did you have then in the final, when it came in and you said, well, we can do this with our HVAC systems and the insulation systems? Did that have an effect on their design and their choices prior to you becoming involved?
We were involved from the very beginning. So we influenced those decisions. We helped them design the wall system, and and the HVAC, there was a lot of conversation about how the insulation systems and the window systems were going to influence the HVAC system, and all those things work together. And so we were primarily involved in building shell and the mechanical systems within that shell. So
I think that's just a point worth highlighting a little bit further is, in the typical scheme of commercial scale design, very often a building owner will work to put together what they feel like they need in a program, and they kind of throw it over the fence and say, okay, Mr. Architect, you're going to design a building that meets this program. The architect says, okay, and he does, usually does a great job of that, and he throws it over the fence to the contractor and says, how much does it cost to build this? The contractor says, okay, well, I'm going to figure all this out, and I'm going to put it out to bid to all my regular subs. And so he throws the plans over to his subs, which is usually the insulation, the HVAC, and the window guy, and the flooring guy, and the finishing guy. And so he's, those subcontractors spend about, 70% of the project budget, and they're the ones furthest removed from making the decisions on the front end. On what we've seen with pretty much all of the ultra-low energy use projects that we've been involved with lately is that as a subcontractor, we're sitting down with a general and with an architect and with the owner and saying, okay, what are your goals? What are the goals that we really all want to hit together? And that way, as maybe I'm just doing the installation, I can really say, okay, here's the cheapest, simplest way that we can do installation that'll really yield a high R value. Okay, and the architect takes that, he runs with that. He says, great, I'm going to design around this system of insulation.
I know the building is right next to a canal. Was there ever any consideration to doing where you do a heat exchange?
Yeah, so the question is whether we considered what's called a ground source heat pump or a water source heat pump to heat and cool the building. It was certainly feasible. That's typically a more expensive system. It's also a much more complicated system, and they're harder to control, especially in the application of having an open flowing water source. Though, anytime you're starting to deal with atmospheric water or surface water, that gets much harder to control. You start to get, critters and minerals and interesting other things inside of your heating and cooling equipment, and makes it not work so well. So, and while they are tremendously efficient systems, and we install a lot of ground source heat pump systems, they can very often represent the lowest operating cost. They do typically have some of the higher installation costs.
Have you ever put one in a restaurant or to help out? I have a cafe and market, and I heat with freezers, and I like not to. It's just so counterintuitive.
Heat recovery.
Yeah, so if we could somehow augment refrigeration with ground source, it would be fabulous.
Well, it kind of depends on how you look at it. What you have in a refrigerator is basically a heat pump. It's an air source heat pump. So you're pumping heat out of the air inside the refrigerator, and you're pumping that heat into the atmospheric air, which is why there's heat coming out the bottom of your fridge. At your restaurant, that heat's probably getting ejected outside your building, or
No, it's
Okay.
in the building. We've never turned
Too
the
much
heat
heat.
on.
oh, okay.
We have to get the building to exhale in summer, and
Got it.
and then we have to cool it. And cooling it is actually easier if we can push the air, the heat out. But it's very tricky.
I don't think that incorporating a ground source heat pump system is the right plan. There have been some really interesting studies done. Whole Foods in Austin, Texas, they have a really, really cool heat recovery system with their freezer cases. And you maybe grab my card and shoot me a note. I'd love to get in touch and at least show you what's been done. I'm not sure if it makes sense for the scale of your cafe. That's another big thing that we start to see is the scale. What would it cost to really engineer that system to work well at the scale that you're talking about? But it's certainly a worthwhile conversation. Russ, do you want to jump on that at all? Okay.
Going back to the Higgins project, you mentioned that the decrease in heating costs was $2,000 or was it $3,000 a year, but that there was an assessment to the individual tenants to pay for utilities, correct? Because it was on 1 meter.
Yeah.
So did he lower the assessment to the tenants once that more efficient system was put in? Because that would reduce his ability.
I don't know for sure, but I don't think so.
Because surely they know they have a more efficient system and they're going to expect to benefit from that financially as well, or will they not? Or how was that? How did that go?
They got their own control out of it. That was their
If
benefit.
they want to be cold, they can save money.
That's a really-
Yeah, as
that's
far
a
as I know,
great
that they did not decrease the utility portion of the rent.
Any idea what the
Yeah.
tenant's response to that was?
No, I don't. It's a very desirable location. They never have a problem filling them, so if the tenants complained, I would imagine they'd probably say too bad, and they might move
I
on.
do think that the efficiency that the tenants now had and the ability to control their own was valuable enough that they would be happier actually than what they had before, which was essentially opening the window in the wintertime.
And
I'm just curious what actually happened.
Yeah.
I mean, I totally understand that. Wonder if they had turnover or.
Yeah, I'm not sure.
Did you-
I really don't know.
Rent
So.
like utilities.
So to follow up as they're doing at the state government right now.
There you go.
Did they change out the interior finishings? Like you said, you reuse the radiators? Is that what you said?
No, I'm sorry. So the question is kind of to what extent did we change the interior of the building?
Of the individual units that we're talking about.
Yeah,
Not just
so-
the corridors.
Yeah, so we went into each apartment space and we ripped out the old radiator because formerly it was a steam system, and we changed the system over to a direct hot water system. So you need a different radiator, different control valves, different piping. So yeah, we did go into each space. This is actually a photo of one of the radiators that we installed.
The photo didn't turn out very well.
Oh, okay.
It's a little light, but we did end up installing brand new European style wall radiators that are designed for hot water.
And they're beautiful. And
Yeah.
they look really, really, really nice. And the only interior changes that they had to make was they had to patch the hardwood floor where the old pipes came up, because they weren't going to be in the same location as the new pipes.
So this was strictly a heating
Yes.
changeover. You didn't do any finishes.
Did you have to add any radiators, or did you just replace the old ones?
Yes, we had to add.
You had to add them in individual rooms or different.
They're all
sections of
studios.
apartments?
They're all studio apartments.
They're all studios. Okay.
Yeah, but the heat output was a little different from the steam to the new
So
one, so we had.
two opposed to one.
Yeah.
Yeah.
And so you had zone valves going into like individual controls, like for like a master bedroom. Did you have
All
multiple?
studios.
The question being, did you have multiple controls per unit?
No.
Not per unit, no.
Because they're all-
One thermostat per apartment.
because they're all studios.
We did put in some extra zone control valves that aren't being used currently for some of the commercial tenants below, so that they could tie into that system later if they end up needing to. One of the interesting parts of a steam system, particularly a steam system with uninsulated pipes, is that you end up kind of heating the rest of the building, all of the walls and all of any place that you have a steam pipe running. If you have steam running through it, it's radiating heat. And so a couple of the commercial tenants had steam piping running right next to them. And so that's some data that we didn't know is how much did their utility bills, they have separate heating systems right now, go up because they weren't getting free heat from uninsulated steam pipes radiating heat into their space. So that's a benefit to the owner and a detriment to the commercial tenants, I suppose, but certainly be something worth looking at.
Well, I can say as a former tenant of Babs, first floor, you know, the Babs, in the winter, to get everything up to the top floor, I would be in like a tank top and shorts, roasting my butt off, and I would open all the windows, even if there was a storm or something. It was very, very inefficient.
My first apartment in Chicago, I did the same thing. It was pretty much impossible.
What did you use for insulation instead of the spray foam to achieve a cheaper?
Yeah, Five Valleys Land Trust. Actually, on my very first, the cover slide, you can kind of see it. Oh, this one's really washed out too. So we use a recycled cellulose product. So it's ground up old newspaper that's treated with a totally organic flame retardant. And then that's mixed with a water-based adhesive. And we spray a little tiny bit of water and quite a bit of cellulose and shoot it into cavities. And you kind of, that was where a lot of the design challenge came in, was this is a really cheap, really effective insulation product that's really great to use on a lot of fronts, and it can be really challenging to retrofit into older buildings. So there's a lot of interchange between us and the architect to say this is what the wall assembly really needs to look like.
And how much cheaper was that than the spray foam?
The question is, how much cheaper is cellulose insulation than spray foam? Extremely substantial. I really don't want to hazard a guess, but it's, yeah. Yeah. You could go to 200% easy.
How about air exchange units? With the last one you mentioned, we had everything so tight. Did you have to put in an air exchange to make sure there was fresh air in the building?
That's a great question, whether we had air exchange. And there are a number of different ways to get ventilation into a building space. We do, at Energetechs, typically recommend what's called a heat exchange, heat recovery system, an HRV. And what that does is that it sucks stale air out of the space that you've already paid to heat. And then it brings in outside air that's fresh, but probably cold in the winter. And you use the heat from the outgoing air to heat up the incoming air through a heat exchanger. But those two air streams don't actually mix. So you're getting fresh air that's been warmed up by your stale air. And that's a heat recovery ventilator system. So that's what we use in a lot of buildings. Five Valleys Land Trust actually didn't use one. I was talking a little bit about the airside economizer system that they use. And that's more common on larger commercial buildings. And basically they're fixed percentages. You're always bringing in a minimum of about 15% outside air. And then that varies to meet the cooling load. The penalty to that is that to deliver the fresh air, they are paying to heat up all of that cold outside air. And it's a gas-fired furnace system. So they're paying directly, and they do end up exhausting about 15% of the air that they've already paid to heat. So it's not as efficient as it could be. Yes, sir.
Follow-up?
Please.
Could you go to your slide where you had all the bar graphs?
Sure.
On the heating and the ventilating? And I'm questioning why it is that you didn't put the VAC in with the heating, because it's really an integral part of it. And are you looking at, will you explain why they aren't together?
Sure.
And a bar.
Absolutely. They're very often, I would say, heating and cooling and ventilation are grouped all together. But it actually, for very efficient systems, it often can work better if you separate out those different systems. And so it's also seasonally variable. So you heat in the winter, that's all you're using your HVAC for, is heating pretty much, heating and ventilating. And then in summer, you're using AC. And it also comes down to source. So the vast majority of buildings are heated with natural gas or fuel oil, vast majority being natural gas. Whereas when you're using cooling energy, that's almost always electricity. So you have a source split as well. So that's why they're typically broken out. Ventilation energy is typically related straight to ventilation fans. And those are run by electricity as well.
The reason I made a follow-up is because you were talking about ventilation and air exchange. And can you talk to us, especially like for a restaurant owner, how it is that you mix what is the percentages, and do you change them between winter and summer? Or do you have you do have duct changes or balancing changes? Or how is it your follow-up maintenance on a yearly basis? Do you have maintenance contracts that come back in?
Yeah, so you got a bunch of questions there.
It's all a change.
And the occupancy and the use is gonna influence how the system gets controlled and what type of ventilation, heating, cooling, and ventilation system goes in. So there's not, I don't have one answer for how to make a recommendation. On Five Valleys Land Trust, they have a maintenance agreement to maintain the equipment, to make sure that it's taken care of. The economizer varies the volume of air that it brings in, summer, winter, fall, spring, to maximize it during this time of year, so they get basically free cooling, and they close it down to that minimum percentage as it gets more extreme temperatures outside.
Focused on cold climate.
Yeah.
Absolutely.
Yeah, and we'd be happy to follow up, a longer discussion.
Yeah,
in
because
more
to me, that's the
detail.
most interesting discussion about the modern code and how ventilation is so important to the occupancy of the building, and whether they're happy or going home and for sickness, how much air you bring in, fresh air you bring into your occupant.
Absolutely.
Depends on where you're at too. Like this would be a different conversation in Phoenix, Arizona.
Very. Go ahead, sir.
One other question, in terms of, thanks for being here, first of all, I'm super fascinated by this, as being a building owner in town here and having tenants. It's a commercial building. In terms of lighting, what have you found as the top couple strategies to reduce, you're showing reduction by 50% here. Didn't talk too much about that. Maybe you just share a little bit in terms of how that reduction is achieved.
Absolutely. The question was around strategies for reducing overall lighting energy. I'm not a lighting designer, and I do not consult on lighting. So I don't want to speak with authority. Dana Lund is the guy that you want to talk to. Okay. Typically, the sorts of things that we can do, you want to look at your window placement. So higher windows, north-facing light is typically better for daylighting. So you get smaller windows that are located higher in your space. North-facing walls can bring in some of that good quality north light, indirect light that doesn't have a lot of glare in it. A lot of commercial buildings take advantage of lighting control sensors that actually will dim the lights in a space based on how much light is it coming in through the window. So that's a sensing solution. And very often in a lot of these lighting studies, when you read into them, they offered controls. So they gave people the power to turn off the light in their space if they didn't need it. That was a huge one. And probably the fourth strategy is really a switch to task-based lighting rather than overhead lighting. So if you're in an office space that has 11-foot ceilings and all of the lighting is done from 11 feet, when really you're looking at something on a desk at 4 feet, it's a hugely inefficient way to do it. So very often, and that actually empowers other new technologies like LED lighting. LED lighting works terribly at 11 feet, but when you mount an LED light 2 feet above your desk, it works great.
Motion sensors and more efficient ballasts on fluorescent lights also are some very simple ways to increase efficiency.
We're out to an hour. If you would all please join me in thanking Skander for the great presentation. I'd also like you to please thank our sponsors for tonight's event: Family Dental, Energetechs, Portico Real Estate, The Loft, the Missoula Independent, Cherry Creek Radio, and Bravo Catering, Big Sky Brewing, and 10 Spoon Wine, and the Liquid Planet for all the food and goods that they brought us. We do have MCAT taking a video of this. It will be on MCAT within about a month. It shows typically 2 or 3 times on MCAT, so you can watch their schedule if you want to rewatch or send some friends to it. And about a month after it airs on MCAT, it will be on both MCAT and the SBC YouTube accounts. So you can send friends and relatives out to see it in about 2 months on our website. So please, I encourage you to spread the word that it's out there for people to use. The next event the Sustainable Business Council will have is Garden City Local Fest. It's going to be June 22nd down at Caris Park. We are encouraging local vendors to join us to showcase their products. Last year, Energetechs was down there with a whole bunch of cool demonstrations on windows and walls and how you insulate and etc. We also have people who are selling products for anything from carpentry, cabinetry work and that sort of thing, to solar panels, to clothing, to toys. We'll have some folks down there who will have displays on health, alternative health strategies, acupuncture, etc. So we encourage you to come down and join us. We, as part of that event, will have our 2nd annual Local Gourmet Chef Challenge, which is 5 local chefs competing to create something with all primarily local product that comes from the Clark Fork Market, which will be running for the first 2 hours that we're down there during the day. So again, that's June 22nd from 11 to 5. If you're interested in vending, there are forms here tonight, but there's also a link from our website out to an online registration, and you can go out and register. The board members would be happy to talk to you about that event afterwards.